Well, hello and welcome to my demo of the robot soccer for assignment 2. As you'll see, I've got here the robot soccer field designed in Webots with 4 robots on it. On the left here, we can see the World Explorer. We've got 2 teams, Team A and Team B, each with an attack player and a goal player. So here, highlighting attack A first, and then goal A next, attack B and goal B. Those are the 2 teams. Over on the right, we've got the control software that's running all of the robots. The attacking players and goalie players, of course, have different behavior. It's in the same code file, but we get different behavior, and different state machine is run based on command line arguments that determine the role of the player. So, for example, attack A player sends arguments attack A to the controller, so it knows which which role it has and which goal it will be aiming for. And the goalie also has the set of code in here. If we've selected role goalie, then that's the one we'll get. So there'll be more on the code, of course, in the report. Let's get on with some of the tests. Well, let's just first of all talk about the robots. The robots are the Pioneer 3DX, handy little robot. It comes with distance sensors, which are very useful for collision avoidance. And we can also, and I have added on a camera, which is used to detect the ball. The ball is bright blue, so the robots can easily identify that from the blue color, detecting intense blue pixels, and that's how it localizes the ball within its vision. The robots also all have a compass, so they know what direction they're facing, and a GPS, so they can find their location and decide where to head towards the goal that they need to. They get no global information from the simulator, so they don't know anything about where the ball is or where the other robots are, other than what they determine from their sensors. So to go through the tests, it's probably easiest to just remove some of the robots, remove 3 of the robots, and just look at one of the robots in isolation. So if I take, for example, this one and line it up to a really simple case, for looking at test 1 to see the robot moving towards the ball, hit play, and it moves towards the ball that it's detected sensors. Now that was pretty straightforward. If we just start with it in this offset location, you see there it found it with its camera, and it turned towards it and found it. If we reset, we can make that a little more complicated, a little bit more challenging for it, where maybe the ball is outside its field of vision. Then it's going to do a hunting maneuver to start with. Just sort of go round in circles, and it would, if it didn't find it, it would have turned back round to the right after a while. So it found that, it grabbed it, and then it can dribble it. But test 1, we're just looking to see that it can move to where it's meant to. Now that was the attacking robot. Let's have a look at one of the goalies, because they've got a different set of behavior. If they can't see the ball, if I say take the ball right off the field of play, then you'll see that goalie just rotates left and right to see if it's looking for the blue ball. So if we just bring that ball back onto the field of play, put it somewhere like here, then you see it's found it. It's looking towards it, and it's just jiggling, keeping that ball in view. And if I move it a bit closer, when the ball gets close enough to the goalie, then it will decide to charge towards it and push it out of the way. So it has a movement where it moves towards the ball as well. So that's what we're really looking at there in test one, seeing the robot moving, seeing some of the general motion is also test three. Let's see. Put everyone back on the world. Just revert to the basic world file. We're going to look at test two. Robot needs to be able to avoid some obstacles. So let's just stick to one goalie and one. Let's get rid of the ball as well. If the robot happens to be close to the wall, and if we start off here for the sake of argument, now we're using the distance sensors on the robot to avoid collisions. There's a collision avoidance technique. So there, it came close to the wall and it decided, and it did a complete turnaround. I think and yeah, it's avoided a collision there. Now we can. That was the wall. There's some other things it can collide with here potentially. So if we get it started close to the goal, those goal posts could be. Yep. I think already that was close enough for a detection, and set it off in its turning motion. Maybe if we'll just try that from a little bit further out. It's hunting at the moment, so that's why it's turning. It's looking for the ball, so it's not really wanting to do a straight line movement. But there, that was it. Detecting that. Now, of course, the robots can have collisions with other robots as well. So let's just set that up. See what happens there. If, say, we just drag this attacking robot over relatively close to this goalie robot. What direction was it going? They'll still both basically be. Well, the attacking robot is hunting for the ball. So if we just pop it somewhere where it's going to risk hitting that other robot, which I think is about there. It detected it, and it's moved away to avoid a collision with that. Still doing that hunting maneuver. So getting close to that other robot. Yes, and there we are. We see it moved away. So that's test three. Test two. Sorry, the robot avoid obstacles and other robots. Let's have a look at test two. We've seen the ball finding technique for both of them, but we can revert the whole thing, get the whole lot. We saw also the goalie defending a goal earlier, but perhaps if we can look at tests 4 and 5 together. Really, that's if I just put it to one player on each side and hit go. Well, this player goes and picks up the ball. And it knows where team A know where the goal is that they're aiming for. So heading towards it, goalie B saw it coming and pushed out. So we end up in a bit of a stuck point there. The goalie successfully defended that goal. We can reset. We can start this player anywhere if it can't see that ball. Remember, it's going to going to manage to find it. It's going to do a bit of a hunting turn here. Oh, there we are. It's spotted the blue and it's navigating towards it. Once it's close enough to the ball, then it chooses to, and so it's close enough that that little feature I've built on the front of the robot is definitely holding the ball. Then it moves towards the goal, and it would have dribbled it into the goal. We could just demonstrate what would happen if there wasn't a goalie there. Maybe if we do a reset and see here. We can dribble it towards the opponent's goal. And actually this works at both ends. We can see just in a moment the other one. So there we are, and you see it actually stopped and just kicked it into the goal there. Beforehand we didn't see that happen because the goalie got to it before it managed to do that. So yeah, if we pick the other two, we've got Team B here on the right. You can see from the World Explorer that attack B and goal A are in play at the moment. And here we go. And so, of course, attack B knows that its goal is down the other end. And the goalie down there has just same goalie basic principles. It just knows it's at that end, so the direction it sweeps through when it's hunting for the ball is 180 degrees rotated from goalie B. Now we'd better see how we perform with everyone on the field. Let's put a whole lot on. The starting positions of these attackers don't really matter too much. In some ways it's quite interesting to have them at different spots. So if we just go there, one of them's found the ball first. That's attacker A, and it's dribbling that ball towards the goal, and the goalie comes out, defends successfully. Attacker B never managed to get it. Let's just basically the sort of behavior we're seeing is in this case, whichever attacker, and the model we've got so far, it's whichever attacker is closest to the ball when it starts, really, is the one that ends up winning it and getting down there. Now, of course, if the two attackers collide, they when they collide head on like that, the collision avoidance doesn't work perfectly. But there we are. We can see that we've demonstrated the robots moving. Both robots, or well, all of the robots actually, can move towards the ball that's detected using the camera sensor. They can avoid obstacles of the robots and so on. We see they've all got appropriate ball finding and motion algorithm being implemented for their role. We've seen the goalies defending the goal, and as the attacking robots dribble it up and attempt to kick it into the goal. So there we are. Thank you for watching this demo of my robot football team.